put in the center?
N.
N. We're looking at number 4. It makes sense to put the N in the center. If we look at them, nitrogen has 5 valence electrons, right? Okay. What else do we have?
3 hydrogen.
3 hydrogen. If I look at my hydrogen, each hydrogen has 1 valence electron, right? Each hydrogen has how many openings? 1, because each energy shell holds how many electrons? The first energy shell? 2. Just 2, so it has 1 opening. If I took these 2 hydrogen and I just put them together and fit them in, are they stable? Are they good? Okay. Does that make the other hydrogen and the nitrogen stable? So does this make sense? Not a good pattern for what we have, right? So when we start looking at our pieces, we want to make sure that we get a setup. Lovely. What if I was ugly? Did you just delete me? I didn't delete it, did I? I'm undoing it. Lauren, you're fantastic. But I really appreciate your question. All right, so I'm not going to put the 2 hydrogen together. That doesn't make the most sense, right? Right? But I still have a hole on hydrogen that I need filled. Nitrogen has how many spaces? 3. Does it make sense? If we know the formula is NH3, does it make sense to fit my hydrogen around in those 3 open spaces? It does. So what I would want to do is get my hydrogen in a spot that's going to make sense. And for you, you're probably not going to move and drag yours around on the paper. But if you write yours then, and take your valence electrons maybe and say, okay, I'm going to take the hydrogen's 1 valence electron, I'm going to put it over on this side, because I know I'm going to make a bond with nitrogen then. It starts to make sense. You can take those valence electrons, you can move them around a little bit, so that when you're drawing these, you can get the most sense for what you're going to put together. Okay? I know you don't want to flip your paper around and write them upside down and sideways, and that gets a little confusing that way. So we can have some flexibility. When I look at my circles, each hydrogen atom needs how many valence electrons? 2. So when I look at my hydrogen, I'm going to say, okay, hydrogen, you're going to share with this one. Because it's closest to you, it makes sense. My hydrogen here, you're going to share with this one. And my hydrogen here will share with that one. And then my nitrogen, it has 5 of its own. It's going to share with those 3 nitrogen. We're going to share with all 3 of them together. And bring it together then. If you look at where the overlap is, I've got a shared pair right here between the red and the black. I've got a shared pair right here between the red and the black. And I've got a shared pair right here between the red and the black. How many shared pairs do I have? 3. So when I draw my structural diagram, I've got my nitrogen with my 3 shared pairs, my 3 individual hydrogen atoms off of it. Do my hydrogens have any extra electrons? No. How about the nitrogen? 2 of them. Yeah, it's got 2 electrons up here that are not shared with anything. So it's got 2 of its own that I would just add in there. So that's what my nitrogen trihydride would look like in the end. Okay? So for right now, I understand they're going to look a little messy for you. But as you get and work with them better, as you get more comfortable with them, they will start becoming neater and easier. And you can predict where they're going to be. So instead of having to erase it 3 times, you can write it down once. You can start to see the pictures. When you look at nitrogen, you can visualize, oh, nitrogen has 3 openings. So it would make sense if I put a hydrogen on each side or on 3 sides of the nitrogen instead of putting it, how many of you put hydrogen on one side and then put 2 hydrogens on the other side when you first wrote it down?
I did.
I saw that a lot. You what?
Valence electrons for nitrogen, so I just kind of moved it.
You didn't know how would you know how many valence electrons?
I
are
didn't
nitrogen?
bring my periodic periodic table home.
I didn't
Do you
either.
know where you can find them?
Online.
I wasn't.
Google periodic table.
Google has the periodic table for you.
Nowhere.
Isn't that handy?
I didn't know what I got.
It's probably more advanced than ours too.
Okay. Excuse me. Let's look at the next one. We've got carbon, and then we've got carbon tetrachloride. Tetra means 4. Okay, so what would make sense for me to put where? C in the middle, and then what should I do with those chlorines? C has 4 valence electrons, right? 1, 2, 3, and 4. Where would it make sense for me to put a chlorine? Andy Larson, where would it make sense for me to put a chlorine?
Right there.
How many openings does chlorine have?
Everything.
1 opening, right? And there's 4 of them. So how many openings does carbon have? 4. Would it make sense to put a chlorine at each opening? Sounds good to me too. So if I put my chlorine over here, I've got my 7 valence electrons. Looks like those two could share. If I put my chlorine down here, I'm going to put my 7 valence electrons that they can share. So when you start drawing these now, each of the chlorines are going to overlap with 1 carbon electron. Giving each chlorine 8. My carbon is going to overlap with 4 chlorine electrons, 1 from each of them. So when you look at shared pairs, 1, 2, 3, 4. Your shared pairs are where your 2 colored circles overlap. Anytime you've got 2 different colored circles overlapping, that's a shared pair. Now my bond structure looks like that. Does carbon have any extra electrons? No. How about the chlorines? How many? 6. Yeah, we've got 6 electrons here that are not being shared. Is it making more sense? Okay. Are you more comfortable putting these together a little bit?
Yeah.
Sophie?
So in this situation, it's not drawing that last circle around the carbon with the chlorines, it's not like an all or nothing situation, they just take 1 from each chlorine.
Yeah, you don't want to do all of these
Right.
electrons because carbon only wants 4. Now, carbon could share 4 with 1 chlorine, but that would not make chlorine happy because then chlorine would have to share 4 back and give it too many. So each chlorine is going to give just enough so that they can both. It has to be a mutually beneficial relationship. Carbon can't just take 4 from 1 chlorine and make it happy because chlorine is not going to allow it. But they could both share 1. Okay. Let's turn the page over. Let's go through a couple more of these. I'm going to make sure you're really comfortable. Your next one is PCl3. PCl3. So set that up. Take a look at where your valence electrons are, and you try and do your setup. So I've got just my individual parts on the board. I want you to put all your pieces in the right spot. spread them out where it makes sense to put them. Where should I put, what's my first thing that I would wanna do? Put what where? Don't all speak at once.
Put the P in the middle.
Put the P in the middle. Why, Ivy, should I put the P in the middle?
So you can put the chlorines around it.
Because I wanna put the chlorines around it. I've got 3 different chlorines. Phosphorus, P can make, or has how many openings? 3. Each chlorine has how many openings? Only 1. So think about that. If you only have 1 opening, chlorine has 1 opening, there's only 1 hole that it can fill. If you put chlorine and chlorine together, they're done. They're not gonna do anything else. So we wanna make sure that we bond in a way that can use up all 4 of these atoms. So if we put a chlorine over on this side, that's gonna fill it up. If I put this chlorine down over here, that fills up that side for phosphorus. And if I put this chlorine over here, that's gonna start filling up that side. And then we start to have something that looks really good. So our chlorine will share 1, share 1, share 1, and the phosphorus is going to share 1 from each to make it full. If I look at where they overlap, I've got a shared pair, shared pair, shared pair, 3 shared pairs, and then a structural diagram that looks like. Okay. Getting better? Huh? Getting better? Okay, I want you to jump down to, let's do number 7 actually. Number 7 looks good. So look at what you have for number 7. You've got 6 parts, I think, right? We have 2 nitrogen. And then how many iodine? Is it iodine? Alright, so each nitrogen has an opening, or 3 openings, right? Each iodine has how many openings? 1. So if I take the nitrogen and I fill up with the iodine, nitrogen's happy, the iodines are happy, looking good, right? Yeah? Is that N2I4? What is this? Ni3. This is nitrogen triiodide. Is that the same thing? So can I leave it like this? No. What do I need to do? How can I get it to fill up instead? Because if I just put this one here, that's iodine's happy, but the nitrogen's not. This iodine, they're not going to do anything with each other.
Could you,
Put the nitrogens together. So I've got to take this iodine away. And you're saying if I put this in here, bond the nitrogens. And then I've got another opening here, right? This. You're saying that's gonna work? Nitrogen has a bond here, here, and here. So this guy's happy. This nitrogen has a bond here, here, and here. That one's happy. Is each iodine bonded? So is every atom stable here? Are we atoms in a good spot? Yeah, so you've got to get a little creative. The iodine, each iodine shares one electron with nitrogen. You look at each of the different overlaps. And then each nitrogen is going to share 2 electrons with the different iodines and 1 electron with the other nitrogen. So if you look at shared pairs, we've got a shared pair here, shared pair here, shared pair here. How many shared pairs do we have? 5 of them. Yeah. Got a lot going on, but it all fits. You get it all put together. Let's have you jump down to number 9. Jump down to number 9. Each nitrogen has how many valence electrons? 5. How many open spots does it have? 3 open spots. So my nitrogen here wants to get 3 electrons from something. It could take them, or it could share with someone else, but it needs 3 spots to fill. The one over here needs 3 spots to fill. If I just took 1 electron from nitrogen, is that going to make either of them happy?
No.
No. Is there anything else that we can bond in here? Could we what? Bond.
The nitrogens together.
Yep, we're going to. If I just bond with 1 electron each though, it doesn't make them happy.
They can share.
What?
Do 3 of them?
Each of them share 3? Can we do that?
Sure.
Sure.
I have no idea.
I don't know. Well, let's try it. What's gonna happen? We take this one and we say, okay, I'm gonna take 3 of you. We're just gonna take the 3 closest electrons. Which will be those. And then this guy over here will take the 3 closest electrons also. That looks kind of funky. How many pairs of shared electrons do we have? We've got a pair here, right? We've got a pair here. What else do we have? Outer 2, right? We got 3 pairs that are shared. Does that work? How many bonds are in between them then? 3 bonds. How many extra electrons go on the outside of each nitrogen atom? How many are unbonded? 2. And this guy? 2. If I look at each nitrogen atom then, it starts with 2 electrons. 4, 6, 8. That's for this guy. 2 electrons, 4, 6, 8. Both nitrogen think they're happy. They're sharing 6 electrons between the 2 of them that are going to rotate back and forth. That triple bond, is that going to be stronger or weaker than a single bond? Stronger, yeah. It's going to be much stronger than what we had in the other kind of combinations that we have. Is it making sense? Okay, do number 8 and number 10 right now. Number 8 and number 10. then we'll check what you have.
Is this number 9?
This is number
10, okay.
Okay, we're good.